Hello students, in today's lesson we are going to learn about balancing simple and complex redox reaction. Thank you. Balancing simple and complex redox reaction. Now redox reaction are reaction in which one species is reduced and another species oxidized simultaneously. That means in a redox reaction, both reduction and oxidation is taking place at the same time. Now, redox reaction also involves transfer of electron from one species to another. That is, one species loses electron, another species accepts the electron that is lost. Now, a simple way to also recall or remember what oxidation and reduction is by using the acronym OIL and RIG. OIL stands for oxidation is loss. That means if there's loss of electron, that is oxidation. While RIG, reduction, is gain. So when there is gain of electron, there is what? There is that is reduction. Now, we have an example here to show oxidation, how oxidation and reduction occur at the same time. We have hydrogen molecule with oxygen molecule giving us water. Now, from here, now you know last time when we talked about reduction or oxidation and reduction separately, one of the definition we gave for oxidation is that oxidation is addition of oxygen. But today we'll not actually be dealing with it on that on that level of either addition of oxygen or removal of oxygen. But we'll be looking at it based on the electron transfer. You see, if you look at this two molecule of hydrogen plus one molecule of oxygen to give us 2 molecules of water, 2 molecules of oxygen, the oxidation number of hydrogen, the oxidation number of hydrogen here is 0 and that of oxygen is 0, and then here that of hydrogen in this equation is +1 and that of oxygen is -2. So you can see from 0 to +1, hydrogen 0 to hydrogen +1, that's an oxidation that is taking place, which means electron is lost. And then from 0 to -2, that is what? Reduction. Now let's take this class activity to identify the oxidants and the reductants, that is the oxidizing agent and the reducing agent. Now, like I mentioned earlier, you see, oxidation and reduction normally happen what? At the same time. So for instance, as the hydrogen gets oxidized, the oxygen got reduced. Now, I want us to identify now again. And that concept I want us to also pick out quickly before we go into work proper is reducing agent and oxidizing agent. You see, oxidizing agents, they will oxidize the other species but get themselves what? Reduced. And reducing agent will reduce the other species and get themselves oxidized. So in this case, oxygen has helped to do what? To oxidize the hydrogen, but itself got what? Reduced from 0 to -2. So that means oxygen here is our oxidizing agent and hydrogen here is our what? Reducing agent. So now I'll be giving you this short activity between copper and oxygen, and then sulfur dioxide and oxygen molecule. So I want you to identify which one is the oxidizing agent and which one is the reducing agent. I also have hydrogen sulfide plus sulfur 4 oxide, and then iron and cesium. So I want us to look at these four simple equations and then try to find out which one is reducing agent or oxidizing agent. As soon as we are done with that, then we will proceed in our lesson. Now balancing redox equation require that you know how to assign oxidation state to different elements or atoms of elements in a particular maybe in an ion or in a compound. So we'll start by what? Seeing how to determine the what? How to determine the oxidation state of what? Of an atom. Okay? By the following rules. Rule number 1. The oxidation state of an individual atom is what? Is 0. So if you have an individual atom, or if you have atom in its uncombined state, for example, if you just have potassium, sodium, oxygen, okay? Now, so the oxidation number of potassium is what? Is 0. That of sodium is what? Is 0. As long as it's not in its ionic state, but it is in its neutral state, or it's just existing as a molecule, like we have in oxygen. So the oxygen number is what? Of oxygen there is what? Is 0. Then rule number 2, group 1 metals. Now, because they are in group 1, they have a tendency to lose 1 electron and become positively charged. So they tend to have what? Oxidation number of what? Of plus 1. And group 2 also has oxidation number of what? Of plus 2, because they are in group 2 and they have tendency to what? To lose 2 electrons and become what? Positively charged. Then rule number 3, oxidation number of fluorine is in a compound is what? Is minus 1. Like we see there, like we have sodium fluoride. So fluorine in sodium fluoride is what? Is minus 1. Chlorine too, the same thing. Bromine too, the same thing. That means the halogens. Then number 4, the total oxidation number of all atoms in a neutral species is 0. Okay, like we have sodium chloride. So the total oxidation number there is what? Is 0. Ammonia, total oxidation number is 0, and so on and so forth. And then the oxidation number of the oxidation state in an ion is equal to the charge on it. For example, if we have this ion, ammonium ion, that is NH4 plus, the oxidation number is what? Is plus 1, because the charge on it is what? Is plus 1, is 1. Then we have sulfate ion with what? With minus 2. So the oxidation number will be what? The oxidation number or oxidation state will be what? Will be minus 2. So it's equal to the charge. So if we have a group of radicals that have 1 or 2, or minus 1, minus 2, and so on and so forth, so it is what they have there combined that is the oxidation state. Number 5, hydrogen generally has oxidation number of plus 1 in compound, except in ionic hydride, where hydrogen has minus 1. Like in lithium hydride, for example, lithium is plus 1, while hydrogen is minus 1. But generally, hydrogen is always what? Minus 1. Then number 6, rule number 6, oxygen generally has oxidation state of minus 2 in compound, except in peroxide, where it is what? Minus 1. When oxygen is combined with fluorine, its oxidation state is plus 2. You can see an example like we have in this compound F2O. Now we have come to our activity 2. Okay, so we're going to do this activity together in the class. And what is the activity? You want to find the oxidation number or the oxidation states of different elements in radicals, in compounds, and so on and so forth. So now let's start with the first one, which says calculate the oxidation number of the underlying element in each of the following. So we have magnesium oxide, we have chlorine molecule, we have sulfate ion, we have chromium ion, and then we have calcium trioxochlorate. So and let's start with magnesium oxide. Magnesium oxide, we have magnesium. If you want to know the oxidation state of, is in magnesium oxide, Mg. That is, magnesium is what is underlined. So we have magnesium, then we have plus, and then we have minus 2, which stands for what? For the oxidation number of what? Of oxygen, and then it's equals to 0, because in one of the rules says when you have a compound that is in its neutral state, the total oxidation number is what? Is is 0, so that's why we have this 0. So magnesium minus 2, because plus minus is minus, we have what, magnesium minus 2 equals to 0. When you make magnesium, so the formula, so magnesium become what, plus 2. Then chlorine is in a neutral state, is a molecule in a neutral state, it is what, 0. Then in SO4, what is underlined was what, a sulfur, so we have sulfur, then plus, then oxygen, and our oxygen, we have 4 oxygen, that is minus 2 times 4, which is minus 8, equals to what, minus 2. Then when you solve for S, you get what, plus 6, that is minus 2 plus 8, you get plus 6. Then number 4, we have chromium, uh that is Cr2O7 2 minus, so we have two chromium there, plus the oxygen for 7 oxygen, and for oxygen we have minus 2 oxygen, then multiply by 7, which give us what, minus 14. And then the total oxygen number in the whole radical is what, is minus 2. So that's how we have minus 2 here. So 2 are minus 14 equals to minus 12. Now when you solve for chromium, you get plus 6. The same thing with Ca, that is calcium trioxochlorate 5. Okay, how do you know that chlorine in calcium trioxochlorate 5 is has an oxidation state of what, of plus 5? Okay, so now we have calcium plus 2 chlorine. If you multiply the bracket, you have 2 chlorine, and then if you also expand the bracket, you have 2 times 3 for the oxygen, so that means you have 6 oxygen, and then the total oxidation state is what, is 0. So plus 2 and plus 2Cl plus 6 times minus 2 equals to 0. When you solve for chlorine, the same way, calculating like times, dividing both sides by whatsoever you want to divide it, like we can see there, here we divided it by 2. The oxidation state of chlorine is what, of chlorine in this compound is plus 5. Now we are going to go through the 4-step process for balancing simple redox equation. Now number 1, divide the equation into 2 half reaction, that is the oxidation and the reduction half equation. Number 2, balance each half reaction for mass and charge. Number 3, equalize the number of electrons transferred in each half reaction. And finally, add the half reaction together to get the overall equation for the balance redox equation. Now let's begin with a simple equation between cobalt 3 plus nickel giving cobalt 2 plus nickel 2 plus. Now looking at this, it appears to be balanced, because we have one cobalt, one nickel. Now with respect to mass, actually it is what, it is balanced, but since there is one cobalt atom and one nickel atom on both sides of the equation, okay, that's why we say it is balanced. Now but look at it here, it is not balanced for charge. Why? Because if you look at the charge, cobalt has plus 3, nickel 0, that means the total charge on the reactant side is plus 3, and then the total charge on the product side is what, is plus 4, because we have plus 2 for cobalt, and nickel we have plus 2 for nickel. So 2 plus 2 gives us what, give us plus 4. Now let's follow the 4-step process that I told you of earlier. The first step says divide or split the reaction into 2 half equations. So we have nickel to nickel plus, and then cobalt to cobalt plus. You see, then now you need to identify which one is oxidation and which one is reduction before you can separate it properly. Then if you look at if you look up, you can see that cobalt is plus 3, from plus 3 to plus 2, which shows that there is what, reduction. So that means cobalt, the change in cobalt is our reduction half reaction. Now when you look at nickel, there is nickel nickel 0, from 0 then it changed to what, to +2. That is our oxidation half reaction. Then in step 2 we balance each reaction for mass and for what, and for charge. Is that clear? For mass, we have said it earlier that we have one nickel, we have one nickel by one nickel here, one nickel here, one cobalt, one cobalt. That means they are balanced. Okay. We say when balancing equation, it should be based on the law of conservation of mass or matter, that says that matter can neither be created nor destroyed. So if you have one here, you should have one here. If you have two here, you should have two here. So that's one has been met already. Now then for charge, we have 0 here, no charge here, but here we have +2. Now to cancel this charge, what you need to do is to subtract 2. And for you to be able to subtract 2, what you do is to do what, to have what, 2 electron. So when you have 2 electron, so that is +2 minus 2, giving us 0. So by stop doing, the charge has been balanced. So we have 0 here, and then we have 0 here, and then we have 0 here. Then when you look at the cobalt equation, cobalt has +3 and then has +2. Now since we have 3 and 2 here, now to balance it, then we need to reduce this by 1 so that it becomes what, 2 2. And how do we do that? By adding 1 electron. When you add 1 electron to cobalt 3, it becomes cobalt 2 plus. Then in step 3, then by so doing, you see the charges are now balanced. Then in step 3 and 4, we want to combine them together. We have what we say, equalize the number of electrons transferred in each half reaction, and then add the half reaction together. Now, how do we go about these two other steps, step 3 and 4? Nickel is already balanced here, and cobalt is already balanced here. Then when you add them together, you can see that we balance here with 1 electron and we balance here with 2 electrons. So now what do you do? So since here is 2 electron and here is 1 electron, you see based on electron they are not balanced. So we multiply here by 1, multiply the nickel side by 1, and then multiply the cobalt side by 2. Then by the time you do that, we have what, 1 nickel 2 plus 2 electron, and then when you multiply this by 2, we have 2 cobalt 3 plus 2 electron, and then 2 cobalt 2 plus. Now if you look at this place, you discover that both the electron, we have 2 electron in the nickel side, and then we have 2 electron in the cobalt side. So you can see that 2 electron can now cancel 2 electron. When 2 electron cancel 2 electron, so at the end of the day, by the time you add, based on step number 4, by the time you add everything together, you see you can have our 2 cobalt plus our nickel to give us what, 2 cobalt 2 plus our nickel 2 plus. You can also check it to see if the charges and everything are balanced for both mass and charge. Then we have our activity 3, endeavor to balance the following redox equation, and then check it with the answers that are provided. Now let's look at how we can balance complex redox reaction. Complex redox reaction are reaction in aqueous solution that involve adding either +1 or that is hydrogen plus or hydroxyl ion, hydrogen ion, and water in addition to the electron to compensate for oxidation changes. In other words, complex reaction are just reaction that they are redox reaction that take place in either acidic or basic medium. So if we have our redox reaction happening or taking place in acidic or basic medium, then we are talking about what, complex redox reaction. Now there are 4-step process. Now the 4-step process we describe in balancing simple redox reaction are applicable with few exceptions. For instance, oxygen and hydrogen are balanced differently in complex redox reaction. If the oxygen are not balanced in either reaction, add water molecule. You add water molecule to the side missing the oxygen. And if hydrogen are not balanced, add hydrogen ion. Then you now add the hydrogen ion to balance it up. Now this is when the reaction is in acidic medium. But to balance it in a basic medium, now instead of what we did in what we would do in acidic medium, in basic medium you add water to the side with excess oxygen, and then you then balance it up with what, with hydroxide ion. Now we're going to get that by the time we start solving the work example. Now we have four work example, two on acidic and then two on basic. On basic. Let's start with the first work example, which is balancing the reaction between iron 2 plus manganese 7 to give us iron 3 plus manganese 2. So the first step, we say you should do what? Identify the which one is the which in which reaction is oxidation happening, and in which one is reduction happening. 2, have equations. Okay, now divide into 2 half equation, the oxidation half and then the reduction half. So from here you can see that iron 2 got oxidized. There's an oxidation between what, iron 2 to iron 3, and there's a reduction between what, between manganese manganese 6, not 7, sorry, manganese 6 to what, to manganese 2. Now how do you know that this is manganese this is manganese 2 or manganese 2, and why this one is manganese? You can see that it has 2 plus here, but here there is 2 minus, but we have a radical here. So you solve for Mn. So by the time you solve, you can see we have what, plus 6. Then from there you go to the second step, where we balance for atom and charge. Balance for atom and charge. After balancing for ion and charge, you go to step 4, where we now balance for electron. So to balance for electron, since there is one electron between, there's just difference of one electron between ion 2 and ion 3, you add what, an electron by the side of what, of ion 3, so that by adding one electron which is negatively charged, that means which is -1, is going to reduce the ion 3 to ion 2. And then for manganese, you can see we have started the balancing from up here. So after balancing, by that is by adding water, you can see that we added water where there is what, we add water where there is no oxygen. And then after adding water, because we have 4 oxygen, so we added 4 molecules of water. And then after adding 4 molecules of water, it now generated 8 hydrogen. So because of that, we since it's an acidic medium, we now add 8 hydrogen ion to this to the other side, so that I can balance the 4 hydrogen by the side where we have our manganese 2 plus. Then from there you can discover that the mass, we have one manganese, 4 oxygen, 8 hydrogen by this side, and then 8 hydrogen by this side. Then the next thing is to balance the charges, because here we have +2 and here we have +6, because we have -2 plus 8, which is what, equals to what, +6. So that means we need the shortage of what, of 4 electrons. So those 4 electrons now, or there's 4 electron, there's difference of what, of 4 electrons. So those 4 electrons will be added to where we have +6, where our charge is excess with +6, so that it can reduce. By the time we add 4, it will reduce the 6 to 2, so that both sides can now be balanced with 2. Exactly. Then after that we add them together and cancel 4 and 4 electron. That is on the ion side, and then on the manganese and manganate side. Then we balance them together. Then at the end of the day, you can also check to see if the complete or the overall reaction is balanced. This is in an acidic medium. Now let's check. Let's take another example in a basic medium, where we have Cr3 plus and then BrO minus. Then we have CrO4 2 minus plus Br minus. Now this reaction is taking place, this complex reaction is taking place on in a basic medium. So now what we did, we will not be adding oxygen, water and hydrogen plus an hydrogen ion the way we did in acidic medium. Rather, what we'll be adding here, we'll be adding water, but with what, hydroxyl ion, because this is a basic medium, and you know what a base is. Okay, one of the a base, we say is a substance that always what ionize to give what hydrogen ion as the only what negative hydroxyl ion as the only negative ion there. So now our first task is to do what is to identify which one is being reduced and which one is being oxidized. So using this, we have seen that chromium 3 plus is plus 3, then chromium uh, tetraoxo tetraoxo that is tetraoxochromate 6. Tetraoxochromate 6 also can also be calculated. Now, when after getting this, we have discovered that it is a chromium that got what oxidized, while Bro minus got reduced, because from Br plus 1 to minus 1, that is reduction, and from Cr plus 3 to Cr plus 6, that is what oxidation. Then we have a half reaction, the oxidation half, and then the reduction half. Then when you spread them out, then you do what? You go ahead and balance each of the half reaction. So after balancing for chromium and then balancing for the bromine, for the bromine side, so in 2 we balance for charge and mass, ensure that if we have one chromium here, one chromium here. Now let's look at balancing it in basic medium proper, the way we did in acidic medium, where we add water and hydrogen ion. Here we'll be adding water and hydroxyl ion. Now how do we do that? Now you look at where you have excess oxygen, so that is where you will add your water. Unlike in the case of the acidic medium, where we added our water where there is what deficient of oxygen. So now look at the side where we have 4 oxygen, that is Cr, oxygen 4 2 minus. So you add 4 because of this 4 oxygen. So we are going to add 4 molecules of water. 4 molecules of water. Now after adding 4 molecules of water, then here there's no hydrogen and there's no oxygen. So from here now you can see, if you look at the hydrogen now, 4 times 2, that means we have 8 hydrogen. So because of that, we are going to add 8 hydroxyl ion. So 8 hydroxyl ion by the side where there is no oxygen or hydrogen, so that they can get balance. As soon as it is balanced, then you can now balance for charges. So you find out the charges, like here we have plus 3 and here we have minus 8. So plus 3 minus 8 gives you what? Minus 5. Then here we have minus 2, here we have 0, and here we have minus 3. So minus 3 minus 2 minus 3 equals to minus 5. So you can see here also that the charge is now balanced. Then you move to the next step, which is what? Balancing the electron. How do you balance the electron? You simply balance the electron by bringing the 2 half equation. You can see that the Br minus to Br minus, where we have excess oxygen, we added water. After adding water, you see we have now generated 2 hydrogen, so we are going to add 2 hydroxyl ion. Then after balancing the water and then balancing it with hydroxyl ion, then we now talk of what? Balancing the electron. You see, from the first place we have minus 1, and then we have minus 1 minus 2. So minus 1 minus 2 gives us minus 3. That means there is difference of 2. There's difference of 2 electrons. So where are you going to add the 2 electron? If you add it here, if you add the 2 electron, that means here will be minus 5. But if you add it here will now become minus 3. So that both sides will now be what? Minus 3 minus 3. So they are now balanced for also what? Charges on both sides. So you take this and add it. You bring this, you bring the bromine oxide side with the chromium 3 plus. Then you look at the number of electrons that was used in balancing each of case. In the first case we have 3 minus, and the second case we have what? We have 2 minus. So what do we do? Since we have 3 up and 2 down, we take the number so that they can balance and become equal, so that the number of electrons will become equal, so that for us to cancel them out. So we multiply the 3 by 2 and then multiply the 2 by 3. So when you multiply 2 here and multiply 3 here, you can see what we get. So for the chromium we have 2 Cr 3 plus 16 hydroxyl ion, and so on and so forth. Then for the bromine oxide, we have 3 bromine oxide minus plus 3 molecule of water plus 6 electron, and so on and so forth. Then 6 electron cancel 6 electron. Then the next step, we add up what the balance half reaction. So have one overall reaction. Okay. Then by the time we add everything together, then you notice something in step 5. What is that? Now in step 5, after adding everything, we discover that we have hydroxyl, we have 16 hydroxyl ion, and we also have what 6 hydroxyl ion on different side. So you have to collect like terms. Okay, you have to collect like terms. In the same vein, you can see also we have 3 molecule of water by our reactant side, and then we have 8 molecule of water on the product side. So now what you do is that when you're collecting your like term, you remove the smaller the one with smaller value from the one with higher value. So since we have 16 here and we have 16 hydrogen ion, and then we have 6 hydrogen ion by the other side. So we cross, you're not crossing multiply, you're going to move this to cross the equal sign to the product side here, from the product side to the reactant side, and become 16 minus 6. And then here where we have 8 molecules of 8 molecules of water, and here we have 3. So these 3 water now have to be subtracted from the what, from 8 water. So at the end of the day, you are going to have 2Cr3 plus 3Br oxygen minus plus 10 hydroxyl ion to give 2 Cr oxygen 4 2 minus plus 3Br minus plus 5 molecules of water. Then you can now check to see if they are balanced, all both mass and charges are balanced. You can check it. Look at it now. We have 3 chromium on the reactant side, two chromium here, 2 chromium here. Look at, we have 3 Br here, and then 3 Br. We have 13 oxygen. Now count the oxygen. You will see that there are 13. You can see that we have 3 with bromine here, then we have 10 with hydroxyl. So 3 plus 10, that is what? That is 13. And then when you look at this side, we have 8 here, and then we have had 5 here. So 8 plus 5 is what? Is 5. So if you look at the overall reaction now, everything is all balanced. So let's take 2 more examples, and then you now be given 2 work to do at home as further activity to help you get better understanding in solving balancing of simple and complex redox reaction. Now let's look at this. We have copper plus nitrogen, oxygen. Okay, that is trioxonitrate 5. Okay, we have trioxonitrate 5 ion here. Then we have copper 2 ions, and then we have nitrogen 4 oxide. Then we have nitrogen 4 oxide. Okay, so you check which one is being oxidized and which one is being reduced. You can see that copper from 0 to +2 is what is the oxidation side. So you are going, so when we go to step 2, where we have our half reaction, the oxidation half and the reduction half. So copper to copper 2 plus goes to the oxidation side, and then nitrate 5 ion goes, nitrate 5 to nitrogen 4 goes to the what? Reduction, because there's reduction from 5 to 4. That is the reduction. And then in step 3, balancing atoms and charges in acidic medium. You remember, say when we want to balance atom in acidic medium, all you need to do is to add water to where there's deficient of water. For example, now we have 3 oxygen here and 2 here, so you are going to add 1 molecule of water to where you have where there is deficient of where the side that is deficient of oxygen. Then when you add the oxygen, then to balance it up, you add hydrogen on the other side. Since in a water molecule there are hydrogen, so by trying to balance oxygen with water molecule has introduced hydrogen, so you have to balance the hydrogen. And how do you balance hydrogen in a redox reaction that happen in acidic medium? All you need to do is to add 2 hydrogen ion. Then from there you now check the charges and see, for instance, here we have -1 and then +2, and then which is equals to -2 plus 2, that is equals to 1. But if you look at this other side, we have NO2, that is 0, the oxygen number is 0. We have also water molecule, which is 0. So we have +1 and 0. Since we have +1 and 0, that means we just need one electron to balance everything up. So here where we have +1, you add one electron, and you know one electron, the value there now is what? Is -1. So 1 minus 1 is 0. So by so doing, everything will now balance. So you can see that we have 0 here and then we have 0 here. Then for the copper 2 plus, you know, there's 2 electron, there is +2, so you just add 2 electron to balance it up. So this equation for copper is balanced, and for nitrate 5 to nitrogen 4 is what is now balanced. Then the next step, which is step 4, balance electron by multiplying the appropriate number. You know, we have, in this case, we have, for copper we have what? 2 electron, and for nitrate ion we have what? We have 1 electron. So what you need to do is you bring the two equations together, multiply the first one, which has 2 electron, by 1, and the one that has 1 electron, you multiply it by what? By 2. Just the same way you do when you are doing elimination during simultaneous equation calculation. And you can see where we calculate, where we find our oxidation state of nitrate 5 and then nitrogen 4 oxide. Then after that, we can now cancel 2 electron. So 2 electron cancel 2 electron. Then the last step is to do what? Is to add the balance half reaction together. Now when you add everything, you see that we have -2 here plus 4, to -2 plus 4 equals to +2, and then we have just +2 here, which is from copper 2 ion. Then when you check for both mass and charges, you discover that everything is what? Balanced. So let's take the last example here. Our last work example is between manganese 4 oxide, manganese 7 and what? And manganese 4 oxide. We have manganese 7 and what? And manganese what? 4 oxide. Now, so here is plus. You can see how we calculate how we got +7 for manganese in MnO4 minus, and then how we got manganese, we got +4 for MnO2. So that means the reduction half is between manganese, the manganese group, while the iodide group is our what? Oxidation half equation, because we are from -1 in iodide ion to 0 in iodine molecule. So separate them into the 2 half equation, the reduction half and then the oxidation half. Then step 3, balance for mass and charge. Now if you look at it, you know, from the beginning we have seen that the iodide ion is just what? Is just only 1, and the iodine is what? Is 2. So you balance the iodide by what? By adding 2 as a coefficient of the iodide. I minus here, so that we now have 2 iodine here and then 2 iodine here. So by so doing, we have balanced mass. Then after balancing for mass, then you now balance for charge. Now that here has become -2 and here is what? 0. So if here is -2 and here is 0, all you need to do is to add 2 electrons by this side where we have 0, so that here will be -2 and the other side also will also be -2. And by so doing, we have gotten our iodide to iodine side equation balance. Then let's go back to manganese 7 and manganese 4. You see, now we need to balance this in what? In basic medium. And don't forget what we said earlier, that when balancing in basic medium, all you need to do is that you look at the side where you have excess oxygen. If you look at the side now from step 3, you see, you discover that it is the side, it is the manganese, it is the MnO4 minus. That is where we have 4 oxygen, while the other side is MnO2 O2. That means the oxygen here is 2. So we have 2 oxygen here, and then we have 4 oxygen here. So 4 oxygen is greater than what? Than 2 oxygen. So you add 2 more water molecule to do what? To this. Now, what is the justification for adding this? What is the justification for adding this? You see, since here, what here you just have only 2. You have only 2 oxygen. Is that clear? So it is what will now determine how many we are. Assuming we have 3 here, we're going to add 3 molecules of water here. So now, after adding our 2 molecules of water by this side, now look at what has happened. Now we have introduced hydrogen. So since we have introduced hydrogen, and in a basic medium, what you need is what? It is hydroxyl ion. So we are going to convert this hydrogen. Now this is 2 times 2 for hydrogen. So that means what? We need 4 hydroxyl ion. So that is how we now add 4 hydroxyl ion here to balance for hydrogen. So oxygen balance, and then hydrogen also balance. Now after that is what we call balancing for mass. Then how do you balance for charge? You look at the charges on them. Here we have -1. Here is 0. Here we have 0. Here is 0, and here we have -4. So we have -1 and -4, and the difference between -1 and -3 and -4 is what? Is 3. So that means you are going to add 3 electrons to one of the side. Then you now decide which side are you going to what? Add this electron. Now here we have -4, and here we have -1. So now to make -1 to become -4, that means we are going to -3. So that means we're going to add 3 electrons, which is now going to become what? -1 -3. So equals to -4, and then the other side we already have -4, which is now balanced. So that is how you balance everything. Then you now go to the last step, okay, where you try to balance for electron. The second to last step, where you balance for electron. And how do you balance for electron? You look at the number of electrons that you have in the 2 equations, in the 2 half equation. Here we have 3 electrons, and here we have 2 electrons. So you can see that the number of electrons are not equivalent, they are not equal. So what you need to do is that here is 3, here is 2. So you multiply the where you have 3 with 2, and where you have 2 with 3, so that by the time you multiply them, you now have 6, so that you can now cancel the 6 electron on one of the half equation, and then 6 electron on the second half equation. Now after doing that, you go to the last step, which is adding up the 2 balanced half reaction together. So by the time we add it, so we have 2 MnO4 minus plus 6 iodine minus plus 4 molecule of water to give 2 MnO2 plus 3 iodine 3 iodine molecule plus 8 hydroxyl ion. Okay, now if you check it, you discover that the atom or the mass is balanced. You also check, if you check the charges, you can see, look at it. Let's just check the charges together now. You see, this is -2, because we have 2 here, and -1 here, that is -2. This is -6, and then this is 4 water molecule. This is 4 molecule of water, which is 0. The ionization number is what? Is 0. There's no charge here. So we have -2 -6, giving us -8. Then let's look at the other side. Here we have what? 0, because this is a neutral molecule. This is also another neutral molecule, which is 0. Then, but our hydroxyl ion, we have 8 hydroxyl ion. That means we have -8. So you can see that the reactant side is -8, and the product side is -8. So we have come to the end of our class today, as far as balancing simple and complex redox reaction is what is concerned. And with what we have done, and the class activity, and the activity that you are going to do, the self-evaluation activity that you are going to do, then you are bound to do what? To understand it. Look at it, it's under activity 4. So as you go home, make sure you do this. You are strongly advised to solve these exercises and cross-check using the expected answer. You can see that I've already provided all the answers to the activity questions. So, and like I told you earlier, they are not meant for you to just cheat on them, but to see how you can do it on yourself without looking at the answers. Then when you, after solving them, you can now come and compare it with your answers. Thank you, and till we meet in the next class.